is Mark, and this is my video for homework 5. Let's just show my room real quick. And back. Here is the formula sheet I'm going to use with the problem statements on the computer that I just shown. Now let's get started. Starting from in the beginning, let's just talk about the general frame of the whole thing. We have 4 reflections in total with 4 different lateral magnification to answer the final question of angular magnification of this telescope. The essential question can be answered by formula m total equals to m1 times m2 times m3 times m4. And then using this, since we're finding the m theta, we can do m theta from m total lateral magnification times s divided by s prime. So these two are the equation we're going to use for this. Moving back with m1 for the first relation. Starting here, we will use the equation 1 divided by s plus 1 divided by s prime equals 1 divided by f, with f equals to r divided by 2. Now here, we can know that s is essentially infinity. This would give us s prime equals to 2 divided by r. For r over here, the first mirror has a radius of 20 meters. We then get 1 s prime equals to 10 meters, s prime equals to 10. This is the first one. Now, we know something interesting is that the focal point is on the right hand. Well, the focal point comes later, but for a concave mirror, the side, it's a reflection out, is the positive side. And since this is a positive s prime, we will have the image moving from the mirror to the right by 10 meters. That subtracted by the 4 meters between this mirror and the next convex mirror, we'll get the image is 6 meters behind the convex mirror. So it's kind of like this. With this information in mind, we can get S2. S2 has that we know. Now we know S equals -6 meters, right? Because it's on the other side of the incoming side. F equals to R divided by 2 equals to -2 meters. It's -2 meters actually, because, well, it's on the other side of the outgoing side. Plugging everything back to the same equation of 1 divided by s prime 1f, we can get that s prime equals to 1 divided by -2 plus 1 divided by 6. Now, factoring out everything together, this gives 1s squared equals to -3, 6 plus 6, 1. S equals to -3, 1. S prime 2 equals to 3 meters. Here is the other conclusion about S prime 2. So we got S prime 2, which is on the other side of it's on the same side as the last image from the first reflection, but it's only 3 meters to the right. So using this, we can start doing part 3. M3 has it such that it has S equals to, well, let's think about this. S is on the incoming side, so it should be positive. It should be 5 meters actually, because it's 2 meters plus 3 meters. F1 divided by F by Lensmaker's equation is that, well, we know that a convex mirror has 1.6 for n minus 1, which gives us 0.6, and R1 divided by 1 divided by R1 minus 1 divided by R2. R1 is essentially following what it just gave me. It's 1 divided by 3 minus negative 1 divided by 3, because for the other side, the focal point is not on the outgoing side. So that's a negative R minus negative R, which is the same R but different sign. It becomes plus the same R. We'll then get this equals 0.6 times 2 divided by 3. Plugging everything we've gotten here into the equation, we get that 1, 5 plus 1 as 3 equals to 0.6 to 3. We get this thing over here. With this thing over here, we would be able to say that 1 divided by S3 equals 0.6, 2 divided by 3 minus 5, 1, 6, 2, 3 minus 1, 5 equals to S3. Everything over here. This will be our final S3. For the sake of our calculation, I will simplify it. So it would then be that's actually a pretty decent number, equals to 5. And 5 is on the outgoing side. Just so I specify this, according to graph, this is the incoming side and outgoing side. So it's 5, it's a positive number, it goes positive on the incoming side. So it goes out on this way for 5 meters. So now we know the newest image is, well, the distance between that and the final lens, M4, is 8 meters, and it travels 5. So it's 3 meters to the right of the concave lens. Since we know that it's on the incoming side, so it's S equals to 3m, S4 equals 3m, which is still a pretty decent number. F1 divided by F, here we go by the same logic. I'm going to simplify some of the calculation, but same thing. Notice here, because it's in this shape, for this one, the focal point is on the incoming side, meaning this one is negative, minus a positive one, which gives you double negative, so become negative 2 divided by 3. Which will actually yield me something along the same line. So it's 1 divided by 3 plus S4 equals to 0.6, 0.25 -2 divided by 3. And yalili yalila, we throw everything onto the other side. We would then get you'll get this thing over here. I'll show you closer for a better look. To solve it, it will give us something preferably very neat. -2. Okay, so this will be the S4 of the final image after going through the comments. S4 means that it's on the opposite side to the outgoing side, so it should form here. This is where the final image will be. Now we can set up equation for m total equals to m1 is -10 divided by infinity times 3 divided by -6 times -5 divided by 5 times 2 divided by 3. Now, solving this, like we cancel out the 2 negative, right? It gives us something that is negative on the top and positive on the bottom. Actually, positive on the top but negative on the bottom, which gives us a negative number. Now, what does a negative lateral transformation means is you put in the image, it comes out as negative. So it comes out as an inverted image. Also, we can get m theta by the equation I have already provided, which is just time this whole thing on the top by s initial is infinity, and s prime here would just be the final s prime, which is -2. So we'll have this crossed out, the negative sign crossed out, and the 2 crossed out. Give us -10 1 times 6 This will be the final angular magnification and that'll be it. We have an inverted image at the magnification of angular magnification at 5 divided by 3. That'll be the end of this video. Thank you very much. Bye.